Hello and welcome to another show of Virtual Coffee with Ashish. For people who don't know me, my name is Ashish. I run a weekly on-demand cybersecurity show called Virtual Coffee with Ashish. The reason the show started was because we could not do any more coffee catch-ups, and I thought, why not do it online? And here I am talking to international people. Who would have thought this would go to that aspect? But I've enjoyed this, and I've enjoyed bringing in different guests about different topics. Today's topic is chaos engineering and how can it help build application resiliency. I have a really awesome guest, as always, who's been working his way through green screens as we've been getting into this, but we've narrowed down really well. For people who are coming in online or watching this from wherever you're watching, if you just want to hit a 1 or a 2 or whenever you guys start seeing this, if you just want to hit with a 1 or a 2, let's just say that you're here, or just say hi, because we love hearing from you guys. So if you want to start with a hi, that would be great. Hi from Melbourne over here. And I've got Aaron Rinehart. Welcome, Aaron.
Thanks for having me, Ashish.
Well, I know chaos engineering is a very interesting topic. I've given a couple of talks about it myself as well, but I've always found it really hard to find the source of someone who's come to that close to implementing it. Like majority of the polls that I ran on LinkedIn, Twitter, and Facebook, majority of the polls, or where one of the options was, yes, I have implemented, and yes, I know about it. Most of the posts were, or most of the responses were either, no, I don't know about it, or yes, I know of it, but never implemented it. So, hey, Darpan. And it's really interesting from my perspective on chaos engineering. I think you and I have been talking about it for almost 2-3 years now, but it was surprising for me that a lot of people knew about it. So I would love to deep dive into it. But before I do, obviously, for people who are listening to you for the first time, who is Aaron Rinehart?
Who's Aaron?
Aaron. Yeah, well, I'm going to go. I want to use that for the next one. Yeah.
No, who am I? So I am the CTO and co-founder of a company called Verica. We are a somewhat stealthy startup, a Series A startup. We are the creators of chaos engineering. Casey Rosenthal is my co-founder. He's the CEO, and he created chaos engineering and ran the teams at Netflix.
Yep.
And basically, we're bringing a more sophisticated set of products to make this easy for people to implement and to get the value from chaos engineering as a practice. If you see anything on Verica's website, you'll see stuff about continuous verification, as well as a good section in the coming O'Reilly book, it just came out.
Oh.
On, I believe Chris.
Yeah, you should probably hold up for a few more seconds. That's right. Thanks. Yep. I got a great shot of it. Yep, that's it.
Actually, if people go to verica.io/book, there's a chance to win a copy of the book if you're interested in getting a free one.
Oh yeah, there you go. Perfect. You guys heard it. You guys heard it over here first. So just go there on the website. I'll leave a link on the show notes as well for this for people to sign up. Curious to know your path into cybersecurity as well, because you have an interesting one, just not a kind of a traditional path. So, can you know what was your path into cybersecurity?
Well, so let's see. So my background extends before Verica. I was the chief security architect of UnitedHealth Group, and at the company, I led the DevOps. I was part of leading the DevOps transformation, cloud transformation, open source transformation. Actually, the first open source tool for UnitedHealth Group, the largest healthcare company in the world, was ChaoSlingr, which was the first ever application of Netflix's chaos engineering to cybersecurity. And we'll talk more about that, I'm sure, throughout the rest of the show. But my background, thematically, probably extends from I started off in systems and network engineering, and then I remember I was more experienced as I was in the learned most of it in the military. I was more experienced than most people, twice my age at the time. I couldn't get the job. I couldn't get a job early on. Even though my experience was all hands-on, but I could get a job on as a software engineer. So I knew nothing about software. So my background in school was finance and economics. I went into investment banking for a short period of time. So I learned software engineering. Basically, I started with databases, and then I worked my way to the front ends, and then I started building my own apps. I'm very thankful for the open source world. That's where I learned most of what to do right. Anyway. I was a software engineer for a little over a decade. and I ended up working for NASA for a number of years. I actually worked in safety and reliability engineering. So
I was going to ask you about the NASA thing as well. Like, what's up with NASA? Yep.
Actually, I got laid off years ago, and NASA was the first place to call me. Like, hey, would you like to come out and work on space stuff? I'm like, space,
Yeah, sounds exciting.
So I went out there to be a software engineer, and I built apps and software applications for safety and reliability engineering. And this opportunity came up to do the security role because one, they didn't want to hire extra headcount to do it, and I'm like, sure, I'll do it, right? So
right.
Then I got into it. Then it turned out to be. Turns out if you're an engineer and you've been a builder most of your career and you get into security, it's a pretty fast accelerant because you can't lie to me how things are really built, right?
Yeah.
But I also have an ability or the facility to receive and transmit empathy, right, with somebody, right? Is that I understand hey, building stuff that's never been built before is hard, right? And I'm not trying to make your life any harder. I'm just trying to teach you on what we have to do to make things secure. Right.
That's right.
That kind of took my career just this way because I wasn't constantly fighting people. I was able to enable them and lift them up. And so from NASA to a bunch of other places in between, but I ended up at United, then I ended up here. So.
Yeah. Thank you. Thanks for sharing that. By the way, before we go into the crux of the questions, cheers. Cheers. What is that, by the way?
It's all whiskey. It's how Americans drink whiskey now.
Oh, American street whiskey.
No, this was actually black tea with aloe vera. It's
Can you do that? I didn't even realize you could do that. But there you go. There's always.
So this black tea has no sugar in it, right? But the aloe vera, the acidity from it, combining with the black tea, kind of makes it like a sweeter kind of taste. So you get that sweetness without the sugar.
Right. Yeah. Because I was gonna say I'm not a black tea kind of person, but black tea with aloe vera may be interesting. Getting into the crux of this, what is chaos engineering? Please just demystify this weird and at the same time mysterious concept for us.
Sure. So I'll give you my definition. So chaos engineering is the idea of introducing turbulent conditions into a system to try to determine the conditions by which a system will fail before it actually fails. Because a lot of times we don't learn about what was wrong in the system until after the fact, or that there was some hidden failure. I'll tell a brief story. Maybe this story kind of helps me explain chaos engineering to people, and sometimes people relate with it better. Early on in our first year as a company, we met with basically 100 large companies across the world. I'm trying to figure out what tech stacks to build to and align to. And we met with one of the largest payment processing companies, and they were talking about how they had this legacy application. They're Casey was talking to him, and I was just kind of eating my lunch, just listening to this conversation. And they're talking. This chief engineer was talking about how we have this legacy application. It basically does 90% of our revenue for the company. It's a trusted application. The engineers know it. They're competent. There's rarely an outage. And we want to move it all over Kubernetes because that product line is scaling and changing, right? But it got me thinking. It was kind of an epiphany. I was like, how do systems become stable, right? Was that legacy system always stable, right? Was it always so well known? Did you always have the right engineers? Was there a lot of times our systems become stable because we end up learning through a series of unforeseen accidents and mistakes or surprises what we didn't know. But often that process itself is incurred, that learning is incurred through tremendous pain. One for the engineers worrying about being blamed, named, and shamed, right, for causing an incident outage. On top of that, customers encountered pain, right? They're frustrated. They may have lost customers, but it doesn't have to be that way. Chaos engineering is a way to proactively inject failure into the system, hypotheses, right? If X occurs, I have to design. I know in my mind for a fact that the system will respond with Y, right? We never do a chaos experiment we know it's going to fail. If you know it's going to fail, just fix it. You're not going to learn anything new. You know it already doesn't work, right? So the idea is to question the system, ask the system questions about things you know to be true, or you think are true. And what's funny actually is the first time you try that, I guarantee you you're wrong, right? Because I've never seen, there may be somebody who gets it right. There's going to be somebody.
I
Right?
love how you put this. So chaos engineering experiment should never fail.
No, it should you should never do when you know is going to fail, because you're not going to learn anything, right?
All
Like,
right.
you
All
should
right. So if you know a system is going to go down, then technically it's a failed experiment to begin with.
Yeah, exactly. So like you just go ahead and fix that thing.
Yeah.
Like engineers, like let me explain it this way. Also, it's really kind of changing the mindset from the post-mortem being the after the fact exercise where you think you know what happened and people spend 3 hours and sometimes they document it well, sometimes they don't, usually only for Sev ones, and then screw everything else because we don't have time for that, because we're going to war room, right? Instead of do all that after the fact, proactively, because people are kind of freaking out during instance, and after the fact people kind of forget what happened, right? And but proactively, your eyes are wide open. It's all rainbows and kittens, right? Like you're not worried about an incident because there isn't one. Like you're proactively injecting these conditions. Hey, did it work? Yes or no? Right? Why didn't it? Okay, rerun the experiment. Yes, it allows you to uncover these hidden failures you didn't know about without incurring the pain. I mean, in general, that's how I like to explain it, and it's the same thing as applied to security.
Interesting, and I think there's a question that just came in that I want to take on as well. You probably should see on your screen as well. Is fuzzing part of chaos engineering?
Fuzzing, so there's a lot of similarity between, actually, I'm glad you asked me that question because I get that question a lot, and I didn't address that in the O'Reilly book, so I'm taking a note of that. So there's actually I just finished a manuscript on the first security chaos engineering O'Reilly book. Kelly Shortridge is my co-author. You guys might know.
Right. Congrats on the book, by the way.
Yeah, thanks. She's usually quite known for her steaming. One, she's an excellent speaker in mind and cybersecurity, but she always comments on RSA and sort of grills them every year. But she's known for that. Swag at blog is awesome.
You're not painting a great picture for Kelly, by the way. Just saying.
No, Kelly is one of the brightest minds in cybersecurity.
There you go. You saved yourself there.
No, you'll get to see her writing. And is fuzzing part of chaos engineering? No, it's not really. Fuzzing is something we do as part of the application security testing lifecycle. I mean, there's some similarities between fuzzing, between red teaming, between purple teaming, and breach and attack simulation tools. There are similarities, but I see fuzzing as a form of testing versus experimentation. So I'll break down instrumentation. So it's a loose definition, but testing is the verification or validation of something we already know to be true or false. What we're really trying to do with fuzzing is kind of ensure that what we think is right is actually right. What we're trying to do with chaos engineering is instrument the system as a whole post deployment. So what happens is, take for an account. Let's say you have a modern software application that's 10 microservices, right? You have payments, billing, RX. I'll be using healthcare because it comes to me easily. You've got medical coding. You got 10 of them, right? You got 10 different teams, probably. Yeah, probably. Maybe they just have the same release schedule. Maybe they're different. Maybe they're releasing 10 times a week, 10 times a day, what have you. So they're all releasing their features and functions and code. The application it gets released, right? For microservices, you never had just have 3 or 4, right? You usually have never had just have one. You usually have 3 or 4 of each.
That's right. Yeah.
But sometimes you have 3 or 4 more because you're running blue-green deployments. You have older versions, newer versions. You're testing out a particular feature amongst a certain user base, so you're kind of rolling things out. But magnify that times the other rest of the 10, right? So you have 10 different groups of humans delivering a different cadences, sometimes the same, and you have all these microservices that you're delivering, right?
Yep.
Sometimes you also have older versions of all those microservices because some other functions are needed for other services because their microservices are not dependent, even though we like to think they are. They're interdependent upon each other, right? And so you have this massive ecosystem of microservices and humans and interactions and changes, right? It's the size, scale, and complexity we've kind of never seen before.
Mm-hmm.
It kind of still applies to or more legacy applications, but I can address that later. But fuzzing is something we more address for each individual microservice, or maybe the front end,
right.
But I'm not saying fuzzing is not important. There are what I'm saying is there's overlaps between the concepts because you're injecting unexpected variables into the system. But what we're trying to exercise is not the microservice itself. We're trying to exercise the emergent properties of what safety and security should be as a system. Like,
so it's like same, but not related, I guess. It's like a cousin to each other, right?
Same, but different, I guess is what I'm trying to say.
Yeah, that's right. Sorry, that's what I was going to say, yeah.
I'll tell you what, like for that question, if that person can, send you, I'll make sure you get a copy of the Security Chaos Engineering O'Reilly book when it comes out.
Oh, there you go. All right, I can coordinate with that because I know Vineet as well. By the way, Charles asked a question about what's the name of the book. Didn't pop the book again on the screen.
Oh, sure. Yeah. And
Charles,
yep.
Charles, by the way, there's a chance to win the book as well if you're interested. What's the website link? Verica.io/book.
Yeah, Verica.io/book.
Charles, you can win it. Good luck, man. Otherwise, reach out. Aaron is a good guy. He loves giving out free books. So just ping me and I'll ping him. Appreciate the support as well. I love the fact that you're offering. So you guys heard it first. If you ask a question, which is good, you get a free book.
Right.
Just come out. Keep asking questions, people. Keep asking questions. Another concept, which is kind of related to chaos engineering, is application fault injection, application resiliency. Like, concept that I used to think is in a very SRE kind of concept. Like, is that related to SRE, or like, and chaos engineering is part of it, or like, how does that all relate? Because you know how every Google search that I did for chaos engineering is more about how do I build application resiliency, and it's all about fault injection. And for people who don't know what application fault injection, you kind of explained it earlier when you were trying to differentiate between fuzzing and application, I guess, what it's like. Is there an example of application fault injection from a cloud perspective? Because I've got a lot of people over here who are primarily working in the public cloud space, and I know you've done some work in the AWS space with Netflix as well and other places. Are there simple examples, maybe one or two examples that you can share for a fault injection, application fault injection, and how can I use that as a chaos experiment to build application resiliency? That's not a long question, but essentially, I'm just after an example of a chaos experiment in a public cloud.
Well, I think it's given the familiarity with people as they responded on the survey with chaos engineering, it's always important to explain. Maybe I'll explain a couple contexts around chaos engineering that most people never talk about.
Yeah, that'd be awesome. Yeah,
I have the luxury of kind of having the beginning of the story more clearer than most people do, and because knowing Casey.
That's why I have you here, man. I wanted to go to the source as close to the source as possible.
Well, I've gotten to know Casey, Bruce Wong, and a number of other people in the space.
The next on my list.
Casey. So Casey really kind of made chaos engineering a thing, right? Beyond just Netflix, right? It started. Chaos. It all started back with Chaos Monkey. Remember, Netflix in 2008, 2009 had decided, you know what, we're going to be bold as a company, right? We're going to change the way we operate, and we're going to define the future by streaming, right? They moved from DVDs to streaming, right? And this is when Reed Hastings also released the memo, said we're going to hire the only senior engineers, we're going to hire the best people, no brilliant jerks, all that, like, all that stuff, right? That memo that changed the world. But like as a process of that, like, so they went forth this ambitious kind of engineering strategy to stream these massive movies over the internet, which is, we all know, one of the number one fallacies of distributed computing is the network is never reliable. So that's gonna be hard to do if the network's not reliable. So what they started doing was, they started building out their streaming services on Amazon Web Services, right? And what was happening is that I didn't address. Let me get back to answer the first question. SRE. So chaos engineering was originally designed as a tool set for SREs. Okay, it wasn't really designed to be a practice or like a job. It was designed to be a series of tools. So back to the Chaos Monkey story, right? So we went to build out their streaming services on Amazon Web Services. What was happening is that remember, this is Netflix's cloud transformation. So a lot of people will tell me, they'll say, Aaron, we can't do chaos engineering. We can barely do the DevOps stuff. We're struggling with the cloud. Whoa. Netflix started doing chaos engineering during their transformation. And I'm going to kind of explain that with the Chaos Monkey story. So as they're building out these services, what was happening is AMIs were just disappearing. It was just a feature of Amazon Web Services at that point in time, right? But they were just disappearing. So what they did
was it a feature? Like how long ago were we talking?
I'm just joking. It wasn't a feature. Nobody knows.
I was gonna say like, wow, it's like great feature, Amazon.
Nobody knows why. Actually, I have a friend of mine that's Kiwi. He always calls them Emmys. So Emmys were just disappearing.
Yeah.
So anyway,
that would be scary. That would be really scary. Imagine like production system suddenly, oh, I can't find the Amy anymore. Like what? It's like, yeah,
right.
Not very reliable.
Well, so what they did was they said, okay, we're going to design our system to be resilient to this kind of problem, right? So we went for it. They built their system to be resilient to that particular problem, and now they need a way to test it. But so they went to Amazon and said, hey, will you provide us a way to do this? And they said, no. That's a violation of our agreement. You can do it all day yourself, right? So they added a tool called ChaoSlingr that during business hours, it will pseudo-randomly take down an AMI. So really what this did was, the point of it was not to cause chaos. The point of it is to put a well-defined problem in front of an engineer. The problem was for an engineer is that during the day, during business hours, when my service is supposed to be running, delivering value to customer, this thing can happen to me. Right. So it turns out if you put well-defined problems in front of engineers, they solve them. Right. And that's really what it's about. It's about providing context to engineers that they previously did not have so they can change their behavior and improve the way the system operates proactively. Proactively is one of the key things. It's not a reactive sort of mean time to detect, mean time to repair kind of thing.
Oh, dude, I think, and to your point about, it's such a mindset thing though. Because wait, are we doing this in production or dev? Like, where are we going? Are we doing this like? Obviously, I imagine me going to my boss, my CEO, and he's like, "I'm going to test chaos engineering in production." How would that conversation go? Like, I can't imagine people saying yes to that easily. So, does it have to be in production, or does it require a mindset change overall?
No, so it is a mindset change. I mean, the cloud was a mindset change. DevOps was a mindset change. SRE is a mindset change. Chaos engineering is a mindset change, right?
Mm-hmm.
I mean, really, chaos engineering is about continuously verifying that the system works the way you think it does, versus so it's there's a vast difference between how you think the system works versus how it works in reality, right? I'm going to get to the dev product question, right? So that what happens is when we design system, it's like systems engineering is a very, 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 very messy exercise. Real work in context is messy, guys. I mean, like, we like to think that there's this beautiful 3D diagram, right? Like, just as an architect, I used to love this. I used to have a solutions architect and a database architect come to me with different diagrams of the same system. Like, our context, our mental model of how we believe the system works is vastly different than how it works in reality. Even if the system works like that diagram day 0, day 1, quickly we move into a series of unforeseen events, right? There's an outage on a payments API, you have to hard code a token, right? Google hires your best engineer, or Atlassian hires your best engineer. New engineers come in, they have to. They're not as new to the code. Like, people make mistakes, people make changes. There's outages. There's scanning results. We have to stop. We have to fix that. Like, slowly, people lose their context of what the system really is, right? So if we're constantly making change to a system we don't really understand, bad things are bound to happen, right? So what we're trying to do is proactively understand that. So when it comes back to this whole prod thing, right? Chaos engineering. Let me just put it in quotes. Let me just put it like exclamation marks. Chaos engineering is not breaking stuff in production. It never has been. It never will be. Right? It's about fixing things. Right? And it's about building a culture of continuous learning, not continuous fixing. And so you can never do chaos engineering in production and still get tremendous value. So there's this example of one of the large retail companies that. They were going to do their first chaos engineering exercise, or what they call game day, which is manual chaos engineering. And they brought Casey in to do a tech talk. So he was still at Netflix then. He went there and they said, Casey, we're not going to do chaos engineering production. We're going to do it on dev. And what we're going to do is we're going to bring down a Kafka node, and we assume another one's going to come back up. And all the, and then there'll be a rebalance, and all the, the traffic and messages will be just fine, right? So what they went forth, they scheduled it. Casey was there, and they actually brought down one of the nodes, and on the dev environment. Because can anyone guess what happened?
No, I wonder if it never came up.
Prod went down, right?
What?
So what happened is they forgot to change
Oh,
the pointer information, right? Because it's real easy. The systems engineering work is messy. It's not that they intentionally did that, but what was great about that was even though they did it in dev, right? They treated it like a real exercise, and all the people that all the people that needed to make the changes, get it back up and running, were there. And they saw it. And it was back up very quickly, right? But like even in dev, they learned a lot about prod, right? Like, and there's a maturity. So with chaos engineering, especially when it comes to tools and the technique, it's always start in low environments. I mean, make sure you understand the tool. Make sure you're competent in the technique. Make sure everybody kind of understands what's going on. We never hide. What chaos engineering we do in the open. We're transparent. Yeah. Everyone should learn from this. You should not trying to be sneaky with it, right? Like,
that's true. That's a good way to put it. I was gonna, because I think you already answered the question from I think that's David Raviv. He's a good guy with New York. He was talking about, tell us a story of epic fails after testing. I think you kind of answered that question already. He's got another question. How does chaos engineering affect readiness in terms of incident response?
Oh God, man, it feels like you're reading my mind. Whoever said that.
This is David Raviv, by the way, great guy.
I can't read at the bottom because I've like anyway.
Right. But did you get the question? It was cool.
So I got it. So actually, this is one of my favorite use cases. I actually started off with chaos engineering for security in terms of security control validation. So I'm going to answer the question. So as an architect, I was always concerned about my recommendations, whether they actually got implemented, whether they're correct, because I wanted to do my job well. I believe in what I did. And I want to help people, right? But I was never sure if my recommendations ever actually made it there, right? And so I need a way to kind of ask the computer, skip ahead of all those people and ask an objective question to the machines, right? And so I was really kind of about security control validation. But the second use case that I found a lot of value in, because when I were demoing the security control validation piece of ChaoSlingr to my boss, the CISO at the time, he's like, Aaron, he kind of piqued my interest. He's like, Aaron, I love the way this helps us validate our controls proactively, but man, it's really a great tool for keeping the incident response team sharp. So I started thinking about, how does this really kind of work in incident response? So really, incident response in general, the problem with its response is its response, right? Is that you're kind of like, no matter how, on the security side, no matter how much money you spend, how much time you spend preparing, how many people you have, you still don't know a lot of things. You don't know when it's going to happen, why it's going to happen, who's trying to get in, why they're trying to get in, and how they're doing it, right? And all that preparation, you're not sure whether controls actually fire in the right situations that you need them to. So what we did was, but chaos engineering, we're not kind of waiting for an event to happen. We're not hoping that when said event happens, things actually all fall into place, right? We're not doing that, right? And also, we're not assuming that when we actually caught the event was the beginning of it, because when you detected it, it's probably not the beginning of the event. And we always love to think of things in root cause, right? Meaning there's one event that caused the damage, right? It's almost it's almost always a multitude of different things and processes and people and things is a process of it, but it's always simpler and easier after the fact to figure out one person or thing. But what's great about the incident response use case with chaos engineering in general is we get to start the event. We're the initiator of that signal, and we can do it whenever we want to do it. We're in control of it. So proactively, we introduce this condition, and now because we know the conditions by which it started, we can kind of remember if in this process there is no real incident. Right? People are not kind of freaking out. We tell people we're doing this. So we can kind of learn, did we have enough people on call? Were they the right people? Were the runbooks actually correct for that type of event? Did the log data actually make sense to a human? Right? When an incident's happening, you're trying to figure out what the hell happened through all this different log dated events and some of it's what the hell does this event even mean? I don't know. Let's throw it away. Let's go with what we can. You're trying to figure things out, and what a timeline is. But proactively, we can introduce this condition, and we can say, hey, did the technology work that it was supposed to? Did we have the right point?
Would this be like a tabletop exercise? Chaos engineering would be part of a tabletop exercise where you have your CEO, CIO, everyone sitting down trying to do a demo run of a runbook of an incident. You could actually have, a dashboard with all the chaos engineering tests you've already done. And it would be, I I just imagine in my head where the entire system has a few experiments going on, and if any of those fails in a tabletop scenario, you have something to fix. But otherwise, then all the known scenarios should not really happen, and you shouldn't really need to have to go down a root cause path for something that you already have an experiment for.
Exactly. So I'll just root cause more holistically in a second, but like, so like once a chaos, I'm a big fan of your initial chaos experiment that you come up with, right? To do it as a manual game day exercise. It's a great exercise, only a few hours. You get the people that are different parts of the business in the same room, and we get to all learn about how the system really works. And like usually pick things that like you expect, like if this happened, like we cover this, like a misconfigured firewall rule. A misconfigured firewall rule. Like we would totally catch that and block that, no problem, right? Everyone gets to test it, but everyone gets to see you're wrong, right? Like, no matter with your firewall engineer, you're the CISO, you're the network engineer that runs the switches, or the load balancer guy person, or the help desk person, or everyone gets to see, oh crap, we were wrong together. It builds this kind of like camaraderie across different functions of people you've never met before. But once you were right, though, once a chaos experiment becomes sort of successful, that you were right about how the system actually worked and you validated it, now you can kind of start thinking, this is where more of the sophistication comes in with the advanced tooling, is that it becomes more of a regression test now, right?
Yeah.
You're constantly running to ensure that those KPIs still actually remain true.
Cool. And just to confirm, so David Raviv does get a copy of the book as well, free copy of the book. He's the guy who asked the question.
Make sure you guys send. I can't see it, so make sure you send like messages to Ashish, and I'll make sure to send your contact info too, so I can.
Yep, I think I've got all these people in my contacts, so I'll definitely be, because I have questions just flowing in, because you've been so generous with your book offer. The questions are just flowing in. I'll just move to the next question. It's from Charles. What impact does it have on automation? Do you have examples of how chaos engineering helps improve security?
Oh my gosh! So I treat those questions as two different things. So how does it impact automation, and how does it improve security? I'm going to address them and then maybe I'll come together with it.
Yeah.
Okay?
Yeah, that sounds good.
So automation. So back in 1983, a woman software engineer actually wrote a 3-page paper called "Ironies of Automation." It has never been disproven, right? Is that there are certain ironies with automation. Is that a lot of people think you need less people, but you actually need more. Once you write the automation, it has to be maintained, and in order to write more automation, you need more people, right? So on top of that, once you replace a skilled function with automation, a skilled series of steps with automation, now you have an unskilled worker monitoring something that a skilled worker used to be able to do. And if the monitoring ends up being wrong, that unskilled person can no longer intervene, but the skilled person could have, right? So over time, if that thing continues to be red or yellow, they just like, oh, that thing is always red, that thing is always yellow. I don't know why, right? And what happens is you need monitoring for monitoring and alerting for alerting. So it's a great paper, and you definitely should read it. It's like 3 pages. There's no excuse for not reading.
Right. Yeah.
Like the point of it is that automation it requires maintenance. It's just code, and there's complexity in it, and it changes all the time. What we're doing with chaos engineering is proactively introduce the conditions by which that automation should be successful, and asking it a question. Like, hey, are you still working the way you're supposed to? Are you still working the way you're supposed to? Because it's not just automation and isolation on like one service or one AMI or one thing. It's a system must have emergent properties, must emerge certain properties as a whole, how it operates, right? And that's where we kind of fall down is it's when all these different things in a complex system start interacting, you get non-linear outcomes. Right, like 1 + 1 no longer equals 2. You get like -3, right, or -4,000, right? It's because the ripple effect throughout the system, right? So you need to constantly verify or continuously verify that the system works the way it's supposed to. Now, on the security side, everything I've said up to this point on this podcast, it directly applies to security, right?
Yep.
As being an engineer most of my career, right, like I never got into that rut where I think that there's a system and it's security. The system is either secure or it's not. Right, and the security is part of the system, what was I say the security suffers from all the same holistic problems in building things. In that we're building at such size, scale, speed, and complexity at today's world. It's so easy to make a mistake, right? And by mistakes, I mean actions and mistakes like a permissive account or leaving a port open that didn't need to be open, or because when you're building things, come on, guys, building things is a process of this. That didn't work. That didn't work. Hey, it kind of works. Hey, it kind of works, right? Like, and it's a combination of that. But like, we're trying to figure out stuff that no one else has figured out. We're trying to build, and like, the process. You're not sure what the lockdown or what permissions you need because you haven't created the objects yet. Like, so like, what happens is, but like we're introducing these changes into this overall larger ecosystem. It's so easy because you didn't understand how how it interacted holistically. You understand your stuff, you might not understand how the rest of things worked. But the security, when you're trying to fit that into that environment, it's easy to make mistakes. So what we're trying to do, if you look at the majority of actually the breach data, it's like the simplest things are causing these problems. It's like, and it's and what we're trying to do is inject these low-hanging fruit into the system. Because if you look at the majority of malicious code, if you can go on like the virus websites and they always have breakdowns of like the steps of code, it will usually require some kind of really stupid thing to exist, right? Like most of it does. There's some advanced stuff. Okay, don't get me wrong, but like the majority of it's crap code. If you're a software engineer, you'd be like, oh my god, this is horrible, right? Like when you look at it, it's like it requires some kind of like permissive account or port or deprecated version of some dependency or software. So what we're trying to do with security chaos engineering, inject those conditions in the system to ensure we can catch them faster than an adversary can exploit them.
Oh, right. And I kind of understand how it kind of affects security, not just security, I guess, and it kind of brings back to the point of application resiliency as well. So, which is kind of security because your availability is one of those pillars of security you kind of have to maintain as well. It's kind of pointless to have a system which is not available 24/7 or whatever the SLA for that is. So I guess Charles gets the book. So I feel like an Oprah moment at the moment. It's just like, you get a book, you get a book, you get a book, everyone's get a book. So Charles, I'll reach out to you as well, man. I've got another question for Vinny. Are there any particular tools that are used for chaos engineering, and are they open source?
Oh, all kinds.
You can drop ChaoSlingr in there as well.
I'll have to drop Chaos. So ChaoSlingr, I left UnitedHealth Group 2 years ago now.
Right.
But like we wrote ChaoSlingr about 4 years ago. It's so with ChaoSlingr, if you go to github.com/ I think it's like chaos/optum. Well, anyway, type in ChaoSlingr, ChaoSlingr, and that's the repo on GitHub. And what you'll find about ChaoSlingr is that one, it's a runnable tool. You can implement it and run the base experiment. But like I left UnitedHealth Group, I was a sponsor of that, so it's no longer really maintained as an open source project. It's still out there. It still represents the framework on how you can write experiments. There are four different functions you need to write. It's all serverless, right? So it's there is generator, there is Slinger, and there is tracker, and then there's the documentation of the experiment, right? So there's generator does target acquisition based upon Amazon reference tags because you there's an opt-in, opt-out kind of function with it. And so it finds the security groups by which you want to actually inject the misconfigured port. Two is tracker. It tracks all the changes, reports them out to Slack. Three is Slinger. Slinger actually executes the opening or closing of a port. So Port Slinger was just the first example. We actually wrote several experiments, but UnitedHealth Group now uses it internally as more of an internal tool, and they actually linked it through their CI/CD pipelines, I believe. Last time I checked, but so in terms of chaos engineering tools in general, there's some great stuff being done. Obviously, Verica, the company I represent.
Of course. Let's check out Verica, of course.
It's more of a commercial tool set. We may open source something at some point, but like we're trying to evolve chaos engineering into the way we do chaos engineering and the way everyone else does it is completely different. We're trying to actually make it more extensible and easier for people to utilize it, but also we don't make up failure modes, right? The kind of failure modes you see from us are actually recreated from the real world. We don't just kill VMs and pods and things like that. We actually have documented from real world companies on how the weird things that really happen to cause failure, and we actually programmatically structured that into a product. and it's really interesting, the kind of stuff that we can learn. So if you're interested, reach out. But in terms of open source projects, I kind of like the Chaos Toolkit. They're all very successful. Russ Miles and Sylvan are good friends of ours.
Right.
It's a great place to learn and how to do chaos experiments in Python. So that also makes it easy. I believe there's an agent involved. So a lot of the chaos engineering tools have agents. So you have to be, we don't, but you have to be concerned with that. I like the Chaos Toolkit. There's one for Kubernetes. Sorry, shoot, what am I thinking of? Written by Bloomberg. I can't think of it on top of my head. Powerful Seal.
Yes, that's right. I was like, the name is right there. And it's a good segue into my next question. Where do you see the trend going between, say, and I think this would answer the question for the next one as well, which is David has asked in terms of when would this go mainstream? Like how long before this becomes mainstream? So curious to know from your side, what are you seeing as a trend from where it was and where it is going? With serverless and Kubernetes kind of on containers now taking over the world. Where do you see that going?
So chaos engineering, I see chaos engineering as a practice in general. I think over the next 5 years, it's going to be more of I think right now we're tracking about 13 to 1,400 companies kind of experimenting and are utilizing chaos engineering. It used to be like Fang and Silicon Valley doing it, right? Or like, those types of companies, right? When it's evolved from banks to healthcare. I mean, the largest health companies in the world are doing it. The largest banks, largest healthcare, some of the largest retail companies. A lot of people have written their own tools in-house. I've actually seen some amazing in-house chaos engineering tools stitched together from the open source stuff and blogs. And what's great is now there's actually what we're missing was a body of knowledge. Now there's a body of knowledge. All the different companies have their own, how they do chaos engineering in here. How they, what the maturity life cycle looks like. It's a great book. But the security chaos engineering one, also, I kind of have a mock-up of the thing of it, but that will have all the companies doing security chaos engineering, which is a little bit different, like I said, from a use case perspective. But you'd be surprised at the companies you see there. They're quite large and quite what you would think is more legacy oriented. But there are things where they had to think differently. And a lot of times everyone who I've talked to that does security chaos engineering comes to me by Aaron. Oh, we actually tried it. But guess what we found out? Our security didn't really work. We found this out proactively. We were able to do something about it. Like we try to make that case to management. It's like, do you want to learn through accidentally finding out something was messed up? Or do you want to learn proactively when you have an ability to do something about it? Right? And that's really what's powerful about it.
Yeah, and I think I'm quickly going to ask, because a lot of people who would be, listening to this, especially the guys who've been asking questions as well, what's the simplest experiment they can start with? Like, does it have to be like a really complicated one, or is it just a matter of whether my SSH ports are open? Is that like a good test? Or because it sounds like it needs to be like a massive test for production to go down, but does it need to be that complicated?
No, it doesn't. I mean, actually, in all honesty, Chaos Monkey, how long did Chaos Monkey just have that simple AMI termination experiment? And they got so much value. One experiment, it's like martial arts, right? Like if you learn one technique and you're just really good at it, right? And then you're dynamite, right? It's kind of the same with chaos engineering. You get good with one experiment, that condition may be true in one instance or one environment, but when you do it to another one, conditions are different. And it's like you get good at one experiment and constantly doing it, you're still going to learn a lot. Just with ChaoSlingr in the port slinger experiment of introducing a misconfigured port, I can actually go through that example if you want me to go through an example of how that works. But
I think it'll be awesome. Because I guess because there's another question that came in from Darpan, which I thought is probably going to hit so the question that came through from Darpan is, after attaining what maturity level in cloud journey or the security posture do you suggest is the appropriate time to start doing these exercises? I think that's a great place to start. And then we kind of go into the example. What do you think?
Sure, let's definitely do that. So almost everyone I know who does chaos engineering or has done it, there's a couple exceptions, are some kind of cloud journey.
Right. So they're not advanced.
right? Yeah, they're not. Even the companies you think, well, the things I learned over the last, this is just me being me, like one thing I learned over the last year and a half, meeting all these different companies, I've been about 100, 120 companies, is that the companies you think are transformed are not. The companies you didn't think were transformed actually are more transformed than some of the companies that say they are. So it's quite interesting. But everyone's kind of like, so when you do cloud transformation, what often happens is most of the time, executives often have unrealistic timelines, right? They always blame the fact they don't have the right people, right? The people that they have don't have the right skills. They need to change. They need to evolve, right? And it's like, if they bring in Amazon or some, I'm not picking on Amazon, but like bring in some cloud provider and their professional service to do it, is the company really learning? Or are you just kind of, like hoping that they'll pick it up in the meantime, right? But like, it's a transformational exercise, right? Meaning that what chaos engineering does is, as you're kind of building things, as you're in there building or let's say refactoring to build what a lift and shift would be to actually a cloud native kind of application, you need a feedback mechanism. It's fundamental in all engineering and science. You need instrumentation testing to know whether something works or doesn't. Engineers don't believe in luck or hope, right? It either works or doesn't, right? So what we need is a way to tell us, hey, it's not working or it's working, right? So what we're doing in chaos engineering is we're injecting what we expect to be working or not, right? And we're doing that. So it's, it could be, when you're, when you've got more of like, I guess I'm trying to think of when the cloud evolution of an app, the way people do things is kind of different, but like when you've got something where you're running in stage that kind of functions, maybe it's a good opportunity to start running some simple scripts against it, right? That's really what you're doing. You can actually do what most chaos engineering experiments do with a bash script, right? Kill a service, right? Bring down a VM, bring down a pod, right? Like see how the system responds, right? See if all the other things that are supposed to occur occurred. So like with ChaoSlingr, let me give you an example, beginning of that example, right? So ChaoSlingr was a primary example of ChaoSlingr because I needed an example that I could explain how to do it to a software engineer, a network engineer, cloud engineer. No matter what you do, everybody kind of knows what a firewall is, right? So we were very new to AWS at the time during our cloud transformation. And what we expected when we introduced a misconfigured port, an open or closed port that wasn't supposed to be open or closed, is we expected a firewall to immediately detect and block it and to be a non-issue, right? And so we started doing this. And remember, a misconfigured and unauthorized port change can happen for all kinds of non-malicious sort of reasons, meaning like somebody couldn't, a lot of software engineers don't understand network flow, and it's a kind of a mindset thinking, and it could be that you just filled the ticket out wrong. It could be that they got implemented wrong. It could be lots of different things could lead up to a mistake or accident, like or intentional change like that. Well, so what we expected, like I said, is that kind of thing is so for security people to think of, like detect and block it, not issue. Well, that only worked about 60% of the time when we started running it. And what the problem was, there's a drift between how we were configuring things in non-commercial and our commercial software environments. And so we were able to proactively fix that because remember, there was no incident. Nobody's freaking out, right?
That's fine.
We learned.
Yep.
The second thing we learned was that the cloud native configuration management tool caught it and blocked it every time, right? The thing we're barely paying for, caught it and blocked the change every time. So that was the second thing we learned. The third, I know, right? The third thing is we expect a good log data to come from both, and it to correlate some kind of event that, hey, this kind of weird thing happened to our SOC, our Security Operations Center. We didn't have a SIM, we had our own log tool, but either way, it still worked. That part worked. Like it correlated the event with the SOC. When the SOC analysts got it, they're like, which AWS account is this, right? Because we were very new to AWS, kind of still figuring things out. And what they found out was they couldn't figure out if it was non-commercial or commercial. Now, as an engineer, you're like, come on, duh, you can just map back the IP address. Well, yeah, kind of, right? That could take a few minutes. That could take 10, 15, 20 minutes maybe, right?
Yep.
And, if this were a real outage, right, that could be millions of dollars. Right? On top of that, you have to account for a production system will probably have SNAT enabled. SNAT will actually hide the real IP address. So you could be futzing around for an hour to 3 hours trying to figure out which actual instance that was, right? And, meanwhile, the system is down. But guess what? It wasn't down, right? Nobody's freaking out. We were able to learn these things, and how things really weren't the way they needed to be. proactively. And this was during our cloud transformation. Cloud transformation, I'm not sure if there's ever really into that. It's just like there's never really into the DevOps transformations are open source, or it kind of just it's.
Is that what triggers it though? Is cloud transformation that triggers these conversations, or is that the right time for it to get triggered?
It's the most common beginning point for all chaos engineering at most companies, is that people are trying to verify that the system works the way they think it does, because they're concerned.
Right.
They're concerned about that story I told you in the beginning, where there's this legacy system. It worked there, worked in our data center. We moved it all over the cloud because we were told all these great things, and we deliver value quicker to customer. And but we're unsure now because those engineers that did that are not the ones doing this. And but now we have a way. So not only do we still do great software engineering testing, unit testing, smoke testing, all that still applies. I've not said we stop any of that. What we're doing is skipping to, Casey and I like to call it the sort of like, once you've achieved CI and CD, there's really this need for a continuous verification mechanism. And that's really what chaos engineering is. That's how we explain it in terms of like with executives. Somebody was asking you that earlier, like, that's more of an adult conversations versus cartoons, monkeys, and other characters. It's really about continuously verifying the system is operationally ready the way we think it is. And that's a better way to structure a conversation.
Interesting. And it's a great example. And I'm just conscious of the time as well. We'll probably have 10 more minutes. But because there's a concept around chaos engineering as a service, and sounds like there's some kind of maturity scale that's required. I'm hinting towards a maturity model in your book, which I've heard of. But is there a maturity model, or is chaos engineering as a service, which is kind of what Verica does, I imagine?
So Verica is not actually a SaaS service. It's on-prem software.
Okay.
Because like a lot of times SaaS services will require like an agent to be on a thing, and like if the SaaS service is compromised, then then you become compromised, potentially. So we find that we're trying to help all companies be able to sort of do this. So when I say it's sort of on-prem software, I mean it can be ran in the cloud. It's just ran inside of your environments. That's
right.
We do it that way. So and we're able to do certain experiments because we write directly to software. We don't require some sort of agent to do it.
Right.
On our side, but
so maturity level how does one find a maturity level? Like does one exist for like a metrics for chaos engineering? What's the metrics for chaos?
There is. I forget what chapter it is in the book.
So it is in the book.
There's a whole chapter in the book on, I forget who wrote it. It could be Nora Jones that might have wrote it. But there's a whole chapter on the chaos engineering maturity life cycle.
Sweet.
And a lot of it is like starting a non-prod, testing out, verifying the open source tool or the scripts you wrote. If you're finding out the open source tools don't do it for you, write your own. I mean, just make sure you open source it so the world can benefit. That's what we struggle with as a community. Is a lot of the tools that have been written inside of companies don't get released because they can't release them. There's actually some great tools out there that just. I agree.
I think another great question came in from David. Probably the last question for this one. What are the elements to building a business case for chaos engineering to get support from business stakeholders?
So it all comes down to, on the security side. So the security use case and the availability use cases are kind of both similar in theme. But it's like, it's that whole, are we going to constantly mature our applications through unforeseen failure? And poor business outcomes, are we going to be proactive about trying to understand that and fixing that? So, one of the, the same thing goes with like security. So with security, the average cost for like per cloud workload for security is somewhere between 25 and 40%, depending on what level of regulation you're required. So you're spending 25 to 40% of all of your budget for an application running in a cloud on security. Would it be beneficial to know how much of that actually works? So what you're trying to do is, and you can't really put a dollar figure on the confidence you get through chaos engineering. It's like when there's a breach that comes out for a certain type of attack, with confidence, like you run this experiment 10 times a day. I know for a fact if that would occur, like we have mechanisms in place, like you can focus your attention elsewhere, right? Where you need, like there's things you may not be thinking about and maybe write new experiments. It's the only way to be proactively identify these types of things before they manifest into catastrophic problems. And it's hard to put a dollar figure on a breach, but man, people are getting tired about hearing the breach had never happened, the outage had never happened with like it's one of the other things that we do, and what Netflix does with chaos engineering, is we try to tie the success of experiments to business KPIs, right? Like you can now explain, this is where we're trying to get to as a craft in general. We're trying to point the craft to is all the technology is not what you're not trying to just build technology. You're trying to build business value, right? So like when Netflix's Chat runs, what it does is it monitors like, not like the technology. It monitors like, stream starts per second. Can people play a movie, right? Sometimes it's checkout carts converted. Sometimes it's signups per hour, signups per minute, or whatever. And like, but you monitor that KPI. If that ever deviates, you stop the experiments because now customers have a bad time during that condition. Report that data back to the service owner, and they get to investigate what happened, right? Like, because if that makes sense, what I'm saying, you now get to explain how you improved product, business value, like customer's experience. That's where you want to go. But like the fundamental premise, you start with the business case and the ROI. By the way, there's a chapter on that in here and putting it together. But you kind of start with like the exercise of being proactive and learning about the system proactively instead of through retroactive failure or customer pain.
And the value that you're putting across is application resilience. So it's the use case is not more you get better security, but the use case is more like your customers can have a much more stable application running or being presented to them instead of this. Because I think to your point, a lot of people may go down the path of going, oh, this is most secure because you've done experiments, but actually it's the other way around where you build application resiliency to have a highly available system or a highly available service for your customers. I think that's probably a better way to put it. Would you agree?
Yeah, you're actually, exactly.
Sweet. So we're kind of towards the end of the interview, and I've got these fun questions, which I clearly, by the way, does David get like 2 books because he's asked like 3 questions? I don't know. You don't have to say this. I mean, you can decide what you want to do, but he's been like really asking a lot of questions. So I'm like, does that mean he gets 2 books? But I'll let you decide that. I'll let you decide that when we talk to him.
Sure.
But so I guess I've got some fun questions towards the end of the interview, which I normally go through, not too personal. So just 3 of them. I want to go through them one by one. What do you spend most time on when you're not working on cloud or chaos engineering or technology?
What do I do in my personal time?
Yeah.
I try to go fishing with my son, to be honest.
You like fishing. You're like a very patient man.
No, it's a way for me to exercise my patience muscles.
I was going to say,
magnification of sucking at fishing and then sucking at it with an 8-year-old and their frustrations magnified yours. It's I just live outdoors.
Patience game going up. Next question: what is something that you're proud of but is not on your social media?
Proud of none of my social media.
Yeah, like a lot of people talk about family and the support they have or something they've achieved. Which like a degree or something personal, like the charity work they would have done. So is there something that you can share?
So I was in the Marine Corps years ago for a number of years. And I designed actually at age 21. I got the opportunity because I knew satellites, radios, phones, and computers. I knew all of that. I was one of the only people in the continent of Africa. And in the
really?
That within the Department of Defense and military,
right?
It kind of there was this huge tsunami in the Indian Ocean, and it really affected the Seychelles, as a country. And I was able to sort of a diplomatic mission. I was able to go over there and design a disaster relief communication network. It was fascinating. It worked, and it ended up being a very successful effort. And I'm very proud. I was really proud of that work. It's one of my life's best work is to be able to work for an entire country. I designed their ability to respond to I guess I've been in resilience for a while. I don't know.
I was going to say, like, there are elements of chaos engineering and application resiliency in there, in that answer that you gave me. A last question. What's your favorite cuisine or restaurant that you can share?
Oh, my gosh. Favorite cuisine.
I know you're a foodie yourself, so I'm keen to know. It's really hard to come up with one answer, but...
what would be my favorite answer? I don't know. I don't know if I could do
What's your go-to? Let's go with that. What's your go-to for like after we get retiring day? Like a burger, pizza?
No, I don't know. What would I go to? I eat so much. My wife is actually Taiwanese, so we eat a lot of Asian food, and
Right.
I don't like to eat a lot of meats, so I also don't like to eat a lot of sugar. So like
That explains the aloe vera in your black tea.
oh yeah, so I don't know. I just try to eat healthy, but I try to eat, I try to have a wide variety of foods. I've lived kind of all over the world, so I've got have we try to just eat different things and different tastes, and but eat healthy.
Wait, thanks so much for that, man. I think eating healthy is always great. I'll say that. I think especially the older you get, the healthier you should eat, just to be just to be normal, I guess.
That's right. So true.
Yeah, yeah. And so where can people find you on social media?
I'm pretty responsive on LinkedIn, and I'm pretty like when I say like here's my contact information. It's like at Aaron Rinehart on Twitter. You can look up Aaron Rinehart on LinkedIn, or you go to Verica.io is my email. I will respond to you, right? No matter what question you ask me. Well, it depends if it gets too personal or something.
Be careful for what you ask for from the internet, but
well, hey, actually, I put that out for years, and people are pretty genuine. Other than like people trying to sell me something, or like I have a pretty good filter for that.
Oh, right, that's good.
If you have a genuine question you want to learn, like no matter whether you're a college student or you're a career professional, I try to help everyone. I believe that's what I enjoy is helping people. But I believe
that's the security community in general, though. Like I've always felt that as well. That kind of like yourself. There's so many people in the security community who are just like us, just sharing free information out there. We just want people to and I don't want to get into the whole gateway topic, but there's this conversation that goes on Twitter about there's a gated approach to getting into security, blah, blah, blah. But I think it's a topic for another time. But I loved this episode, man. And I think the comments flowing in also gives me the sign that a lot of other people loved it as well. So thank you so much for your time. And I can't wait to have you come again, because clearly I had so many more questions, and I feel like all of those are unanswered. So I can't wait to bring you back on again on the show.
Well, thanks, Ashish. This was great.